In this video we're going to prove that sin A plus B is sin A cos B plus cos A sin B. Our starting point for this proof is a previous proof, the cos of A minus B formula. Now what we're going to do is we're going to do this particular substitution. A we're going to replace with 90 minus A, or pi over 2 minus A in radians. And that happens everywhere obviously that we find A, so A is replaced here, here and here. And just let's see where that leads us. So if you do that, you end up with cos pi over 2 minus A minus B. And you can take out the minus outside a bracket, if they're both minus, and you get A plus B. Now over here, we get this result. And just to explain what this result is, come down here for a minute. You take any right angle triangle, if that's the angle A, well that's the angle 90 minus A. And you notice something when we get our ratios. The cos of A is the cos of A is adjacent over hypotenuse, x over z in this case. But the sine of 90 minus A is the same result, opposite over hypotenuse, which is x over z. So you notice that the cos of an angle is the same thing as sine of 90 minus the angle, and vice versa. You get the sine of A opposite over hypotenuse, x over z, the exact same thing as the cos of 90 minus A, y over z, adjacent in that case over hypotenuse. So this is a general result we can use, and that's what we have up here. The cos of 90 minus an angle is the exact same thing as sine of the angle. Same here, the sine of 90 minus an angle is just simply the cos of the angle. And now we have this result, sin A cos B plus cos A sin B. And one last thing over here on this side, using the same logic, there's a 90 minus an angle again. Now the angle itself is A plus B, that doesn't matter. With 90 minus this, the cos of 90 minus this green angle is the sine of the green angle, going by this triangle down here, which is the sine of A plus B. And there's the proof, sin A plus B is sin A cos B plus cos A sin B.